I come up with one more topic in logical reasoning. Topic name is dice and cubes. Tani Pachikalu Mariyu Ganalu Anta. Dice and cubes. What is die? What is cube? What is the difference between both? Okay, we will discuss one by one. Let us start by taking one small diagram. Just focus on this diagram, everybody. Non-math students, just think how I am drawing this diagram. Okay, I am taking the structure of the cube, you can say, no issue. Cube or die, anyhow both are same. Usually I need to say one point here. Usually we will play with the colors, right? We will match the colors. That is called Rubik cube. Rubik cube is the best example for cube. Okay, I think you know about that. It is having red color, yellow color, some green color, combination of colors will be there. We have to mix the colors. Okay, that is the example. That is called Rubik cube. Rubik cube is best example for cube. Okay, simply in one word we can say. Okay, now I am taking one diagram. That is, it is in square shape. Again I am taking one more square. So like this, I am taking one more square like this. Okay, mathematics students, you already know about this. Okay, non-maths students, be aware about this structure of the cube. Structure of the cube. Simply join all the corners. Okay, just name it here A, B, C, D, E, F, G, H. Okay, there are 3 points about this diagram. Okay, this is the example for cube we can say, or die we can say. There is no difference between cube and die. The only difference is cube means it is simply a plain structure. Dice means it is a numbering. I am giving some numbering on the surfaces of the cube. If I am giving any numbering on the surface of the cube, then it is called simply a cube, what we can say, a dice we can say. Okay, I hope you understood. There is no difference between dice and cube. The only difference is cube means it is simply a plain structure. Dice means I am giving or I am assigning some numbers or some colors or some keyboard signs or some kind of what you can say different alphabets, English alphabets on the surface of the cube, then it is called simply a die. Okay, nothing more than that. Both are same. Okay, this is the example for cube you can say, or die we can say. Think that example for cube. Okay, so now about this diagram we are having 3 points. Point number 1 is a cube is having total 6 surfaces. A cube is having total 6 surfaces. That is first point. Similarly, a cube is having simply 8 corners. A cube is having simply 8 corners. And third one is a cube is having simply 12 edges. That's it. Okay, there are 3 points regarding this diagram. A die or a cube is having 6 surfaces or simply faces. It is having 8 corners. Okay, or it is having 12 edges. Okay, this we will discuss by taking one small concept. Okay, that we will see. Okay, so I already told you a cube is having 6 surfaces, 8 corners and 12 edges. Okay, this we will discuss by taking a small what you can say box. This is not the example for cube, but with this I want to show the 8 corners, 12 edges and 6 surfaces. Remember, this is not the example for cube because it is not having all the surfaces, not in what we can say square shape, all surfaces. See, this is in square shape, but this is in rectangle shape. That's why this is not the example for die. With this I am going to show the only edges, corners and surfaces. Okay, remember, now we will see the 6 surfaces of the cube. See, this is top and bottom. These are the 2 faces, top face, bottom face, 2 faces. Similarly, front face, back face. These are the 2 surfaces. Similarly, right face and left face. These are another 2. So total we are getting 6 surfaces. I repeat, top face, bottom face, front face, back face, right face, left face. There are 6 surfaces of the cube we can say. Now we will identify the what we can say 8 corners. 8 corners. See, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corners. మూలలు అంటాం. 6 తలాలు 8 మూలలు 12 అంచులు ఉన్నాయి అంటాం. 12 edges. Now 8 corners are 1 2 3 4 5 6 7 8. These are the 8 corners on the cube. Similarly 12 edges 12 అంచులు ఉన్నాయి అంటాం. See, observe here, 1 2 3 4 5 6 7 8. These are the 8 edges and 9 10 11 12. Therefore we are getting total 12 edges. I repeat once again, 1 2 3 4 5 6 7 8. These are the 8 edges and 9th 10th 11th and 12th. So hence a cube or a die is having 6 surfaces, 8 corners and 12 edges. Okay, just keep in mind. Now by using this concept we are going to discuss some other models. Okay, so this is about what you can say, cube, 6 surfaces, 8 corners and 12 edges. By using this I want to say one point, that is, suppose think that all 6 surfaces of the cube are simply painted. I repeat, all 6 surfaces of the cube are simply painted. ఆ ఘనానికి ఉన్నటువంటి 6 ముఖాలకి ఏదో ఒక రంగు వేసాం, పెయింట్ వేసాము అనుకోండి. ఓకే, నౌ లెట్స్ సే ఐఎమ్ టేకింగ్ వన్ డయాగ్రామ్. జస్ట్ నాన్ మ్యాథ్స్ స్టూడెంట్స్ focus on this diagram. Okay, it is something what you can say different diagram, just focus on this diagram. Okay, so with this diagram we are going to discuss 4 different points. Okay, then we'll wind up and we'll go to different concepts of dice will go. Okay, right, just focus on this diagram. Okay, it is simply a 3D picture. It is not possible to show on board, but simply I am trying to show. Okay, so now see, simply I am jointing these 2 corners. Okay, so now it is like a Y shape. I hope you understood this concept. Okay, take 2 parallel lines, add 2 edges, add these 2 edges and take as a Y junction. Okay, Y shape. See, now observe here, I am dividing into 4 parts. 1 2 3. Indirectly 4 parts I am getting. So here also dividing into 3 parts. So 4 parts by taking 3 lines, 1 2 and 3. Similarly I am dividing this also by using same concept. See, observe here, 1 2 and this is 3. Okay, so now again this one, observe here, jointing these 2, this one and this one. Okay, so again I am taking another 3 lines, 1 2 and 3. Now jointing these 2, see, observe here, jointing these 3 lines also. Okay, with this diagram what I want to convey is I painted all 6 surfaces of the cube. ఆ ఘనానికి ఉన్నటువంటి 6 ముఖాలకి కూడా ఏదో ఒక విధంగా పెయింట్ వేసాను అనుకోండి. ఓకే, this is the concept involved here. See, I am assigning some numbers. So let's say here 3 3 3, here also 3 3 3. Wherever corner is there, simply at that corner, wherever corner is there, simply at that corner I am taking 3. At that corner I am taking 3. Okay, at remaining places simply I am taking 2 2 2 2 2. I hope you understood. At remaining places I am taking 2 2 2 2. At remaining places I am taking 2 2 2. Why this 2, why this 3 and all we will discuss one by one. Okay, why I am taking 2, why 2, what 2 is indicating, what 1 is indicating and all we will discuss. Okay, at remaining places take 1 1 1 1 1. Okay, similarly 1 1 1 1. So here also what you can take, 1 1 1 1. Okay, all blacks are numbered. Okay, just non-math students, pay attention here. Think that a cube is there, cube is painted all 6 surfaces. ఆ ఘనం యొక్క అన్ని ముఖాలకి ఏదో ఒక పెయింట్ వేసాం అనుకోండి, then we come across the following 4 conditions. We will come across the following 4 conditions. Condition number 1 is some, and one more thing I am doing, I am painting all the surface of the cube and I am dividing into various small unit cubes. I repeat, it is a big cube. I painted all 4 surfaces and again I am dividing into what you can say, various small unit cubes. Let's say it is the big cube. This big cube is again divided into various small big cubes, small unit cubes. Okay, big cube is divided into various small unit cubes. ఆ పెద్ద గణాన్ని చిన్న యూనిట్ గణాలుగా డివైడ్ చేశాను. Since it is 3D picture, I drawn like this. Okay, so now we come across the following 4 conditions. Okay, condition number 1, out of these various small cubes, some cubes are painted 3 surfaces of the cube. Some small cubes are painted 3 surfaces of the cube. Some small cubes are painted only 2 surfaces of the small cube. Some small cubes are painted only 1 surface, and some small cubes are not painting at any surface. Okay, there are the 4 following conditions. When I am painting all, see, imagine that Rubik cube. Okay, painting all 6 surfaces, dividing into various unit cubes. If you will observe, small blocks will get. Okay, so now if I'll choose that what you can say, small block, we come across 4 conditions. Condition number 1 is that small cube may be painted only 3 surfaces. Maximum only 4 can be possible. Okay, beyond 4 it is not possible. Even though it is having 6 surfaces, only 3 surfaces can be painted at maximum. Okay, so now similarly, some small cubes are painted only 2 sides, some small cubes are painted only 2 sides, some small cubes are painted 1 side, and some are not painted anytime. 3 times 3 sides painted, 2 sides painted, 1 side painted, and no side painted. Okay, these are the 4 different things. So now, based on this concept, 4 different beautiful points. Point number 1 is, observe carefully, point number 1 is small cubes with 3 surfaces painted. Small cubes with 3 surfaces painted will be present on the corners of the big cube. I repeat, dear students, once again, small cubes with what you can say, 3 surfaces painted. Small cubes with 3 surfaces painted will be available only on the corners of the big cube. Similarly, see, observe here, wherever 3 is indicating, think that it is a corner. So on the corner, maximum how many faces can be painted? Only 3 surfaces. So let's say, just take out this block. If I'll pick up this block, or else if I take out this block, you will get the small unit cube. In the small unit cube, front side, right side, and top side, only 3 sides painted. Another 3 sides it is not possible to paint, because so here these 3 sides are inside the what you can say, big cube. It is not possible to paint. So means 3 sides can be possible. Okay, these 3 sides painted unit cubes are available only at the corners of the big cube. Okay, similarly, 2 faces painted will be present on the edges of the big cube. Okay, so observe here, this is one edge. On this edge, so 2 surfaces painted will be present on the edges of the big cube. కేవలం 2 ముఖాలకు మాత్రమే రంగులు వేయబడ్డటువంటి చిన్న గణాలు అనేవి పెద్ద గణం యొక్క అంచుల వద్ద కేంద్రీకృతమై ఉన్నాయి అంటాం. Okay, I repeat this sentence once again. 2 surfaces painted. The small cubes with the 2 surfaces painted will be present on the what you can say, edges of the big cube. Okay, that is about that. Similarly, so this is about edges. Similarly, only one surface, small cubes with 1 surface painted, will be present on the surfaces of the big cube. Surface of the big cube. కేవలం ఒక ముఖానికి మాత్రమే రంగు వేయబడ్డటువంటి చిన్న గణాలు అనేవి పెద్ద గణం యొక్క ముఖాల పైన కేంద్రీకృతమై ఉన్నాయంట. See wherever one is there. Observe this one. Just take out that. Observe this one, this one, this one, and all. If you observe all these numbers, what you can say? One is indicating that block or that small cube, that unit small cube is painted only one side. 2 is indicating painted only 2 sides. 3 is indicating painted only 3 sides. Maximum 3 sides can be possible. Even though 6 surfaces are there, maximum we can paint only 3 sides. That too, it is available only on the corners of the big cube. Okay, 2 surfaces on the edge and what we can say, 3 surfaces on the corners, 2 surfaces painted, what we can say, small cubes are available only on the edges. 1 surface painted is available only on the surface of the big cube. Okay, similarly no face painted will be present on the inside of the big cube, will be present on the inside of the big cube. Okay, so now there are some numbers, then there are some numbering also. Okay, I repeat once again these 4 points. I repeat once again. Cube painted all 6 surfaces, divided into various small cubes. Now the cube with 3 surfaces painted will be present on the corners of the big cube. Now small cubes, some cubes or small cubes, 2 surfaces painted will be present on the edges of the big cube. Now third point is small cubes with only 1 surface painted will be present on the surface of the big cube. Now last point is small cubes with no surface painted will be present inside the big cube. Observe here, for inside cubes there will be no painting. Okay, that's why there is a concept. Now based on these 4 points we have 4 different formulas. We need to learn 4 formulas also. Point number 1 or formula number 1. First formula is the number of small cubes with 3 surfaces painted is always equal to 8. I repeat this sentence once again. Number of small cubes with 3 surfaces painted will be only 8. This is fixed always. Why it is only 8 means 3 surfaces small cubes will be present only corners of the big cube. Since a big cube is having only 8 corners, that's why we will get maximum 8 cubes with 3 surfaces painted. So 3 ముఖాలకి కూడా రంగులు వేయబడ్డటువంటి చిన్న గణాలు అనేవి పెద్ద గణం యొక్క మూలల మధ్య మాత్రమే ఉంటాయి. సో అవి మనకు 8 ఉన్నాయి కాబట్టి అవి మనకు మొత్తం 8గా తీసుకుంటాం. 3 వైపులా కూడా రంగులు వేయబడ్డ చిన్న గణాలు అనేవి 8 ఉన్నాయిగా తీసుకుంటాం. ఓకే, దర్ ఈస్ నో ఫార్ములా, ఇట్ ఈస్ ఫిక్స్డ్. సో రిమెంబర్ దిస్ ఈజ్ ఆల్వేస్ ఫిక్స్డ్ ఈవెన్ దో ఐఎమ్ డివైడింగ్ ద బిగ్ క్యూబ్ ఇంటూ వేరియస్ స్మాల్. యూ మే divide the small cube into 8 equal parts, or what you can say 16 or 64 or 128 and so on. Divide the big cube into various small equal parts, it won't change, because however I am dividing into the big cube to various small equal parts, you will get the 8 corners only. These 3 surfaces painted small cubes will be present only on the corners, that's why it is always 8 fixed. Now observe here second point is 2 surfaces. The number of the cubes, remember non-math students, number of the smaller cubes with 2 surfaces painted, the number of the smaller cubes with 2 surfaces painted is always equal to n minus 2 into 12. n minus 2 into 12. Okay, I repeat this formula once again. Number of small cubes with 2 surfaces, number of small cubes with the 2 surfaces painted is always equal to n minus 2 into 12. I will say what is n, because n will come here and n will come here also. For these 3 formulas at a time we will discuss what is n. Okay, so now we will go for third point. It is about one face painted. Okay, the number of small cubes with only one surface painted, number of small cubes with only one surface painted is always equals to, we can take n minus 2 whole square into 6. n minus 2 whole square into 6. Okay, we will discuss what is n. Similarly, number of small cubes with no surface painted, number of small cubes with no surface painted is always equal to, simply we can take n minus 2 whole cube. These are the 4 different formulas. 3 surfaces painted is always fixed. 2 surfaces painted formula is n minus 2 into 12, and 1 surface painted formula is always equal to n minus 2 whole square into 6, and no surface painted formula is always what you can say n minus 2 whole cube. And apart from these 4 formulas, 4 points. 3 surfaces painted small cubes can be available only on the corners of the big cube. 2 surfaces painted small cubes can be presented only on the edges of the big cube, and 1 surface painted can be small cubes are presented only on the surface of the big cube, and no surface can be painted small cubes are presented on the only inside the big cube. Okay, so these are the 4 different formulas and 4 different concepts. This is about small case regarding cubes. Okay, so just now we have seen the cubes part, painted cube part. Okay, there are different concepts involved in that. That too, mainly there are 4 different concepts involved in that. Okay, how many are painted, how many are not painted, how many 2 sides painted, 1 side painted, 3 sides painted, and all we have seen just now. Okay, now we will focus on dice part. Okay, now dice part. Okay, before going to start the different concepts in dice, I need to say 3-4 points. Point number 1 is, I already told you the shape of the die. It is, the best example is Rubik cube. Okay, because all surfaces are in a square shape. Okay, this is the best example. Think that a die is rolled. There are 3-4 points. Think that a die is rolled. If a die is rolled, then at a time we can see only 3 surfaces. Even though a die is having 6 surfaces, if I am rolling a die, then I can see only 6 surfaces at a time. I cannot see all 6 surfaces. That's why I have seen just now drawn the what you can say colored cube. How many faces are there? Only 3 faces. If you observe here, front face, right side face, and top face. Okay, so if you throw a die or if you rolled a die, at a time we can see only 3 surfaces. Remaining 3 surfaces it cannot be possible to see. At a time we can see only 3 surfaces. That is one point. And point number 2. Second point is, here what I mean to say is, if one die is rolled 2 times or 2 dice are rolled 1 time, we can treat it as a same event. I repeat this point once again. Usually these beautiful concepts are available at intermediate level. Okay, so even though you are not from maths background, no issue, we will discuss in detail. 1 die is rolled 2 times or 2 dice are rolled 1 time, we can treat it as same event. Or 1 die is rolled 3 times or 3 dice are rolled 1 time, same event. Or 1 die is rolled 4 times or 4 dice are rolled 1 time, treated as only same event, and so on. Okay, so keep this concept in mind. And when a die is rolled, we can see only how many surfaces? 3 surfaces. And we know already a die is having total 6 surfaces. On 6 surfaces, usually we assign the numbers from 1 to 6, but it need not be numbers every time. Sometimes we may assign English alphabets, or sometimes we may assign the symbols on computer keyboard, or sometimes we may paint with different colors, or sometimes we assign some different dots also we can say. Okay, so now I'll show you one by one. So let's say I am indicating the structure of the cube in different way. If you are from science background, you are aware about this diagram. This is called Benzene shape. Benzene ring antam kada, Benzene shape. So but remember, it's not a Benzene concept. Okay, this is one structure. Okay, similarly take 2 parallel lines, joint these 2, and similarly joint these 2 and draw the Y junction in that. Similarly take 2 parallel lines, okay, joint these 2 and joint these 2, so like Y junction shape. Similarly take 2 parallel lines, joint these 2 and these 2 like Y junction shape. Similarly parallel these 2, so jointing these 2 like a parallel shape. Okay, so why I am drawing all these things means 6 surfaces are there, but at a time we can see only 3 surfaces. So let's say on these 3 surfaces I assigned some numbers like this. Okay, so 1 comma 4 comma 3. Okay, you 1 2 6 1 2 3 4 5 6 are available, but I took only 3 surfaces. Okay, and assigned numbers. Similarly here what I can say, we can assign English alphabets also. We may assign English alphabets A, B, C, D, E, F. Okay, like that. Or else sometimes we may assign some different symbols available on computer keyboard. Some different symbols available on computer keyboard. @ hash, star, less than, greater than, and so on. Okay, are different symbols. Dollar symbol, you know already. And sometimes with dots also. Okay, sometimes with the dots also we may assign. Sometimes dots also we may assign. Okay, so here 1 dot means number 1, 2 dots means number 2, 5 dots means number 5, and so on. Okay, and sometimes we may paint the surface also, painted. So let's say on the surface I painted red, here I may painted yellow, so here I may painted green. Okay, like this there are different numbers I may assign, or alphabets, or signs on computer keyboard, or dots, or like the symbols. Okay, this is one point. And next point is, let's say I am taking one different diagram. See, same 2 parallel lines joining these two. Okay, so now like this I assigned some numbers. Let's say this is 1 2 3 and 1 2 3. So here think that this is 4, and think that this is 5, and think that this is 6. Okay, at a time we can see only 3, remaining 3 are what we can say behind that. దాని వెనకాల ఉంటాయి కాబట్టి అది ఇండికేట్ చేయలేం, since it is a 3D picture, 3-dimensional diagram. Okay, so now one thing is clear from this diagram. 2 is on top, the number 2 is on top surface. What about the number on bottom surface? So 2 and 4, these two are always opposite to each other. This sign is indicating opposite. It need not be like that, but for our convenient I have taken like this. So 2 what we can say, by implication part we can say 2 by implication 4 means 2 is opposite to 4, vice versa 4 is opposite to 2 also. And similarly now take this 3 and what we can say, 6 we can say. Observe the diagram, 3 6. And similarly what we can say, 1 5 we can say, 1 5 we can say. What does it mean? 2 is opposite to 4, 3 is opposite to 6, 1 is opposite to 5, and reverse also. 2 is opposite to 4 means 4 is opposite to 2, and 3 opposite to 6, 6 is opposite to 3, 1 is opposite to 5, 5 is opposite to 1. Okay, this is one point. Just now I told you 2 points. Point number 1 is what? 1 die is rolled 2 times, 2 dice are rolled 1 time, treated as same event. That is one concept. And when a die is rolled 1 time, then at a time we can see only 3 surfaces. That is second point. Now the third point regarding this dice is, in a die every surface is adjacent to 4 of its surfaces. Nice concept. మళ్ళొకసారి, పాచికలో ఒక ముఖాన్ని ఆనుకొని 4 ప్రక్క ముఖాలు ఉన్నాయి అంట. In a cube or in a die, both are same, cube or die, no issue. So earlier these are the cubes, since I assigned some numbers, now they became dice. Okay, simply. Now we will discuss dice part. Die, every surface of the die is followed by 4 surfaces. ప్రతి ముఖానికి ఆనుకొని 4 ప్రక్క ముఖాలు ఉంటాయి అంట. Every surface of the die is adjacent to 4 of its surfaces. That is one point. And the next point is, in a die opposite surfaces never be adjacent. In a die opposite surfaces never be adjacent. పాచికలో ఎదురెదురుగా ఉండే ముఖాలు ఎల్లప్పుడూ కూడా మనం ఆ డైని ఎన్నిసార్లు త్రో చేసినా కూడా they never come adjacent. Okay, these are the 5 beautiful points. Point number 1, 1 die is rolled 2 times or 2 dice are rolled 1 time, same event. Point number 2, if a die is rolled, then at a time we can see only 3 surfaces. Point number 3, third point is, what we can say, we can assign either numbers, alphabets, signs, dots, and etc. Third point. And fourth point is, in a die every surface is adjacent to 4 of its surfaces. Okay, that is one point. Fourth point. And fifth point is, in a die opposite surfaces never be adjacent. ఎదురెదురుగా ఉండే ముఖాలు ఎల్లప్పుడూ కూడా ప్రక్కన ఉండవు అంటాం. ఓకే, these are the some 4 different concepts involved in this. Okay, so you can ignore this part. Okay, simply I can say you can ignore this part, even though you don't know anything about this, simply you can omit this. But there are 4 rules in this dice part. If you are aware about these 4 rules, then questions can be solved by using only these 4 rules: rule 1, rule 2, rule 3 and rule 4. Okay, these 4 rules are mandatory, very important. So based on these 4 rules, questions may come in exam. Okay, now we will focus on the 4 rules. Okay, I already told you regarding dice part, there are 4 rules are available in dice. If you are aware about these 4 rules, then you can solve any type of question from dice part. Okay, so remaining part you may learn, you may not learn, that is up to you, but this part you must learn. There are only 4 rules are available: rule 1, rule 2, rule 3 and rule 4. Okay, rule 1, rule 2 something easy, rule 3, rule 4 somewhat confusing. It's not difficult, I should not say difficult, it is something logical. Okay, focus on these 3 rules. Any kind of problem from dice can be solved by using only these 4 rules. Okay, let us start by discussing rule 1. In rule 1, for example, let's say this is one question, think that, and this is second question, first question, second question. Now these two diagrams in first question are indicating the positions of the 2 dice. He will give like this: the positions of the 2 dice are given below. These are the positions of 2 dice. Okay, so here let's say I am taking the numbers 1, 5, 6. Here I am taking the number 1, 5, 6, and whereas here let's say 1, 4, 3. These are the numbers I have taken. Okay, example number 1 once again. Positions of the 2 dice are given. In all the examples, remember, a die is having 6 surfaces. On all the surfaces I am assigning only numbers. That's why, what does it mean? You have to get 1, 2, 3, 4, 5, 6. 6 numbers. 1, 2, 3, 4, 5, 6 numbers. Okay, so if you will observe here, how many numbers are visible here? Only 3 numbers. I already told you, if your die is rolled, we can see only 3 surfaces. That's why on one surface 1, on this surface 5, on this surface 6. What about remaining 3? Remaining 3 are back side to this. Since it is 3D picture, we cannot see, it is not visible. Okay, similarly here 4, 1, 3 given, 4, 1, 3 given. In rule 1, what is saying is, the positions of the dice are given below, or the 2 positions of the dice are given below. Out of these 2 positions, one number is common. In these 2 dice, how many numbers are common? Only one number is common. So here 1 is there, and here also 1 is there. Write all the numbers adjacent to the 1. Write all the numbers adjacent to 1. So here 1 is common, writing all the numbers adjacent to 1. Here 1 is adjacent to 5 and 6, whereas here 1 is adjacent to 3 and 4. Okay, so now one number left. There are 6 surfaces, only I am getting 1, 3, 4, 5, 6. One number left. So here which number left here? The number 2 left here. What does it mean? So here we say that the number 1 and number 2, these both are always opposite to each other. I repeat this condition once again. The 2 positions of the dice are given below. Out of these 2 positions, one number is common. Write all the numbers adjacent to that one. One number will be left. That number is always adjacent to this common number. ఒక పాచికని 2 సార్లు దొర్లించాను. దొర్లించగా లభించినటువంటి పటాలలో ఉమ్మడిగా ఉండేటువంటి సంఖ్యకి ప్రక్కన గల సంఖ్యలు రాయగా ఒక సంఖ్య మిగిలిపోతుంది. ఆ మిగిలిపోయిన సంఖ్య అనేది ఈ ఉమ్మడిగా ఉండే సంఖ్యకి ఎల్లప్పుడూ ఎదురుగా ఉంటాయి అంటాం. ఓకే, ద పొజిషన్స్ ఆఫ్ ద డైస్ ఆర్ గివెన్ బిలో. అవుట్ ఆఫ్ దీస్ 2 పొజిషన్స్ one number is common. Writing all the numbers adjacent to this one number will be left. That number is always adjacent to this common number. Now what we can say, here 1 is adjacent to 5 and 6, 1 is adjacent to 3 and 4. One number left. Which number left here? 2 left. Therefore 2 and 1 both are always opposite to each other. 2 is opposite to 1, 1 is opposite to 2. Now see, observe here, let's say 3 comma 4 comma 5, no issue. So here 4 comma 1 comma 2, no issue. So in this, the two positions of the dice are given below. How many numbers are common? Here also only one number common. So here 3 is there, 3 is not common. Here 4 is there, 4 is there. So 4 is the common. Write all the numbers adjacent to 4. Write all the numbers adjacent to 4. What I am getting? 3 comma 5 comma 1 comma 2 I am getting. One number left. So which number is not appearing here? 6 is not appearing here. What we can say? These 4 and 6. These 4 and 6 are always opposite to each other. Rule number 1 is, it's very clear. You need not to worry. Two positions of the dice are given below. Two positions of the dice. Two positions of the dice are given below. Out of two positions, only one number common. Write all the numbers adjacent to one number left. That number is always, what you can say, opposite to this common number. That is rule number 1. So now rule number 2 is, both are very easy. Rule number 2. In rule 2 is saying like this. How? The positions of the dice are given below. The positions of the dice are given below. So in these dice, if we eliminate the common numbers, then remaining numbers are always opposite to each other. So what does it mean? Let us discuss by taking one example. So here let's say 3, 3, 1, 5. So here 1, 4, 5. Okay. So here I am taking 6, 3, 2. Here I am taking 3, 6, 1. Now observe here. So in these two examples, in rule 2, two numbers must be common. In rule 2, two numbers must be common. I repeat, two positions of the dice are given below. Two positions of the dice are given below. Okay. Eliminate the all common numbers. Eliminate all common numbers. Then the remaining numbers are always opposite to each other. ఒక పాచికని 2 సార్లు దొర్లించినప్పుడు లభించిన పటాలలో ఉమ్మడిగా ఉండేటువంటి సంఖ్యలని తొలగించగా మిగిలిన సంఖ్యలు ఎల్లప్పుడూ ఎదురెదురుగా ఉంటాయి. See here, observe here, write all the numbers. All the numbers are, what I am getting, 1 comma 3 comma 5. Here what I am getting, 1 comma 4 comma 5. So if you will observe here, in these two examples, here 1 is common, 5 is common, 1 is common, 5 is common. So 1 comma 5 are always common in these two cases. 1 comma 5 are always common. Then if I eliminate these numbers, if I eliminate these common numbers, then remaining numbers are always opposite to each other. What does it mean? From example 1, which number is opposite to 3? So therefore 4 is opposite to 3 or 3 is opposite to 4. I repeat rule 2 once again. Two numbers must be common in two dice. Eliminate those two numbers. Remaining one number is available on dice 1 and one number is available on dice 2. So therefore these two numbers are always opposite to each other. ఒక పాచికని 2 సార్లు దొర్లించగా లభించిన పటాలలో ఉమ్మడిగా ఉండేటువంటి సంఖ్యలని తొలగించగా మిగిలిన సంఖ్యలు ఎల్లప్పుడూ ఒకదానికి మరొకటి ఏ విధంగా ఉంటాయి? ఎదురెదురుగా ఉంటాయి. See, observe here. Here also beautiful concept. 3 and 6 common. 3 and 6 common. So what you can say here? Here 2 left, here 1 left. So remaining numbers are always opposite to each other. Hence 2 is always opposite to 1. This is about rule 2. Okay. Rule 1, rule 2, it's very easy. And rule 3, rule 4, somewhat logical concept. It's not a difficult thing. It's a logical concept. Rule 1 and rule 2 once again. Two rules once again. Rule 1. You can logically, you can remember like this. In rule 1, only one number common, whereas in rule 2, two numbers common. Rule 1, only one number common, whereas in rule 2, two numbers must be common. Okay, you may think logically in that way. Okay. Now rule 1, positions of the dice are given below. Okay. So positions of the dice are given below. One number is common. Writing all the numbers adjacent to 1, then one number left. That number is always adjacent to what you can say, this common number. That is rule 1. In rule 2, two numbers must be common. Positions of the dice are given below. Eliminating all the common numbers, then remaining numbers are always opposite to each other. So here two numbers must be common. Remaining numbers, here 3 left, 4 left. These two are opposite to each other. So here what I can say, 2 left, 1 left. 2 and 1 are always opposite to each other. Okay, these are the rule 1 and rule 2. Now we'll discuss rule 3, rule 4. After that we'll discuss some examples. Now we'll focus on rule 3 and rule 4. It's a logical thing. You need not to worry about that. It's a logical part. Just you must have a keen observation. See, observe here. I am taking numbers like this. Here let's say 4, 5, 3. Here what you can say, for example 3, 1, 6 I am taking. Okay, that is one example. Question as follows: the positions of the dice are given below. The positions of the dice are given below. So if you observe here, in these two dice or in these two positions, how many numbers are common? Only one number is common. That is, so here 3 is common. Okay, 3 is common. Since one number is common, according to rule 1, which number is not appearing here? 1 is there, 3 is there, 4 is there, 5 is there, 6 is there. Which number is not appearing? So here it's very clear, 2 is not appearing. What does it mean? 2 is opposite to 3 according to rule 1. But I am discussing what? Rule 3 here. It's not rule 1, rule 3. So in rule 3, of course, here 3 is common, but you need to focus on one more thing. That is, the position of the 3 is occupies same surface in both the cases. What does it mean? Here 3 is occupy on this surface, whereas here 3 is also occupy on this surface. For example, I am taking one more 2 examples, rough examples. So let's say I am taking one question. It's a rough question. Let's say here also numbers as follows. I am taking numbers like this. Here 4, 5, 3. So here 3, 1, 6. If you will observe here, of course, here also 3 is common. But is this 3 occupies the same position, same surface? No. Here 3 is on this surface, whereas 3 is on that surface. That's why, so I am not talking about this case. Okay, I am talking about one number is common. That common number is always occupies on same position or some same surface. So here 3 is there, here 3 is there. So if it is the case, then simply we say that 5 is opposite to 1 and 4 is opposite to 6. 5 is opposite to 1 and 4 is opposite to 6. So here what you can say now, 5 is always opposite to 1, whereas 4 is always opposite to 6. That is the case. See, observe here, we can take one more example. Let's say 1, 2, 3. Okay, and here 5, 6, 2. I took like this. How many numbers are common? Only one number is common. So what is the common number here? 2. Yes. Is this 2 occupy the same surface? Yes. So here 2 is there on this surface. So in second case also 2 is on same surface. Since 2 is occupying on same surface, then the numbers on remaining surfaces are also opposite to each other. So what I mean to say is, here 3 is opposite to 5 and 1 is opposite to 5 and 3 is opposite to 6. I repeat. Okay, 1 is opposite to 5, 1 is opposite to 5 and 3 is opposite to 6. Rule 3, it's a logical part once again. According to rule 1, one number is common. According to rule 3 also one number common. But that common number should occupy on same surface in all the given diagrams, in all the given phases we can say. So 2 positions of the dice are given below. Here 3 is common, 3 occupies on same surface. So here also what we can say, 2 occupies on same surface. So if it is the case, then the numbers on remaining surfaces are also opposite to each other correspondingly. What I mean to say, so here 2 is common, 1 is opposite to 5, 3 is opposite to 6. Okay, so now we can find out the difference between rule 3 and rule 4, so that you may get some idea. Difference between rule 3 and rule 4. In rule 4 also one number common. See, chalo, we'll take one example. 3, 4, 5. 3, 4, 5. Or else I am taking like this. 3, 4, 5. Okay. Next 6, 3, 1 is there. 6, 3, 1. So no issue. Here I am taking 3. Here I am taking 6. Here I am taking 1. Okay. Now observe here. How many numbers are common? Here only one number is common. Okay. But is this the number, common number occupies on same surface? No. In rule 3, common number occupies on same surfaces in both the cases. But whereas in rule 4, of course one number is common, but this common number is not occupying on same surface. So here 3 is on this surface, whereas in this diagram 3 is on top, whereas here 3 is on side, left side we can say, there top we can say. Okay. So in that case, then corresponding numbers or the remaining numbers on corresponding faces, they never be opposite to each other. So usually let us say here now what we can say, 4 is there, here 5 is there, 5 and 1. You should not say that 5 is opposite to 1, because 5 and 1 are on corresponding faces, surfaces. That is why instead of taking 5 and 1 are opposite to each other, we can say 5 and 6 are opposite to each other. And next number what? 5, 6 left, and 4, 1 we can say, 4, 1 we can say. Rule 4 is somewhat logical part. Okay. So here interestingly, in rule 1, in rule 3 and in rule 4, in rule 1, in rule 3, in rule 4, one number must be common. In rule 2, two numbers common. Rule 1, one number common. Rule 2, two numbers common. Rule 3, one number common. Rule 4, one number common. But it is about position. Is that one number occupy the same surface or not? If it is same surface, okay, remaining also correspondingly opposite. So if it is not occupying on same surface, no issue. Okay. See, what I mean to say is, now we will discuss one more example. Here 1, 4, like 3. Here 5, 4, 6. See, observe here, how many numbers are common? One number is common. What is that common number? So here 4 is there, here 4 is there. Is this number 4 occupies on same surface? No, only one number common, but it is not occupying on same surface. So at that time, usually 1 and 5, these two are corresponding surfaces, but these two should not be common, since common numbers are not occupying on same surface. Here in this rule 3, common numbers are occupying on same surface, common numbers are occupying on same surface. That is why corresponding numbers are also opposite to each other. So here 2 and 2 occupies on same surface, 3 and 3 occupies on same surface. That is why 5 is opposite to 1 or 1 is opposite to 5. 4 is opposite to 6 and 6 is opposite to 4. So here 1 is opposite to 5 and 3 is opposite to 6. But whereas in rule 4, only what I can say, only one number common, but that common number is not occupying on same position. Okay. So that is why here 4 is there, 4 is there. Now 1 and 5 are corresponding positions, but these two should not be common. What we can say, 1 is opposite to 6 we can say, 1 is opposite to 6 we can say, and what about 3? So 3 is opposite to 5 we can say, but which number is opposite to 4? Means again by using rule 1, because one number is common, taking all the numbers adjacent to this 4, one number left, which number left? 2 left, hence 4 is always opposite to 2. You can apply, if you have a little bit idea, we can apply it together, rule 1 together, rule 2, rule 3, all 2 or all 3 or any 2 together you can apply. Okay. Once again I need to focus on these 4 rules, then we will start the bits. Rule 1, one number common, writing all the numbers adjacent to that, one number left, that number and this common number always opposite to each other. In rule 2, two numbers must be common, eliminating those two numbers, remaining numbers are always opposite to each other. Rule 3, in rule 3 also only one number common, but that common number should occupy the same surface in both the diagrams. Hence remaining numbers on surfaces are also opposite to each other. In rule 4, again one number common, but this common number should not occupy the same surface. Hence the remaining numbers on corresponding surfaces should not be opposite. Okay. So these are the rule 1, rule 2, rule 3 and rule 4. Now we will start some bits. Okay. Now let us start some questions. Okay. Remember, 4 rules are very, very important. Sometimes in question 2 positions may be given, or 3 positions may be given, or 4 positions may be given. See here, in question number 1, in question number 2, only 2 positions of the dice are given, whereas in third question 3 positions, whereas in fourth question 4 positions. However, he may give the numbers sometimes dots or sometimes colors or sometimes alphabets, sometimes signs on keyboard. However, but 4 rules must be applicable. Okay. Based on the 4 rules we can easily solve. 4 rules sometimes together we may apply, or randomly we may apply. Okay. So now let us start by discussing one by one question. See, he given question like this: positions of the dice are given below. Positions of the dice are given below. Find out the number opposite to the number in the brackets. In each and every question, one here 5 is in bracket. Indirectly, we have to find out the number opposite to 5. We have to find out the number opposite to 2. We have to find out the number opposite to 1. We have to find out the number opposite to 6 by using only rule 4 rules. Rule 1, rule 2, rule 3 and rule 4. Okay. Let us start by discussing one by one. In first question, we have to find out the number opposite to 5. It's very clear. See what is given. How many numbers are common here? 2 is common, 3 is common, 2 is common, 3 is common. See, observe here. 2, 3 and 2, 3. These two numbers are common. Since two numbers are common, we have only one rule, that is rule 2. In rule 2, two numbers are common. Okay. Now what you have to do? We have to eliminate these two common numbers. Here 2 is common, 3 is common, eliminate these two. 2 is common, 3 is common, eliminate these two. Now remaining numbers are always opposite to each other. What does it mean? So 5 is always opposite to what? 6 or vice versa. 6 is opposite to 5. This is how I am getting answer, by using rule 2. Remember, by using I am writing condition also. By using rule 2, answer is what? 6. It's simple concept. In rule 2, two numbers are common. Eliminate all the numbers, all common numbers. Two numbers will be left. These two numbers are always opposite to each other. So clear? 2 common, 3 common, 2 common, 3 common. Eliminate 2, 3. Remaining numbers are 5 and 6. They are always opposite to each other. That is about first question. In second question, he asked to find which number is opposite to 2. Positions of the dice are given below. Which number is opposite to 2? Now what you have to do? See here, 2 is there, 2 is there. Is there any other number common? No other number common. Here 2 and 2. Only one number is common. Since only one number is common, we will apply rule 1. In rule 1, now we have to write all the numbers which are adjacent to this common number. Common number is how much here? 2. Take all the adjacent numbers to this 2. What I am getting? 1, 3 in first diagram. In second diagram, 5, 6. Now one number will be left. Which number left here? 4 left, because 4 is not appearing. Okay, 4 is invisible. 4 number left. Now this 2 is always opposite to 4. Simple. By using which rule? Again by using rule 1. Okay, I need to explain this concept once again. By rule 1. By rule 1. Only 2 is common. 2 is common here. 2 is only one number common. That common number is 2. Since only one number common, that 2 asked to find out which number is opposite to that common number. That's why I am applying rule 1. So according to rule 1, 2 is common. Writing all the numbers adjacent to 2. Here 1, 3 is there. 5, 6 is there. Now one number left. This number is always opposite to 2. According to what? Rule 1. See, interestingly, instead of asking 2, suppose he asked to find 1 or he asked to find 5. Now what he will do? It's very clear. Suppose if in this question, instead of asked to find rule 2, for example, he asked to find which number is opposite to 5. Which number is opposite to 5. Now what he will do? So here 5 is available here. Now we will apply which rule? We will apply rule 3, because one number is common. That common number occupies the same position. Here 2 is on same surface. Here also 2 is on same surface. That's why according to rule 3, what you can say? 1 is opposite to 6, 3 is opposite to 5, like that. Okay, but he asked to find which number is opposite to 2, not 5. Hence I applied rule 1. Okay, randomly. However, you can apply any one rule. Now focus on third one. See here 3 given. Whenever 3 given, if it is 2 diagrams, no issue. Whenever 3 are given, 4 are given, no doubt you can choose any 2. Here 4 given, you need not to consider all 4. You may consider, you may not consider. Here 3 given, consider any 2, no issue. Out of 3 or out of 4, you can consider any 2. Ultimately, by using 4 rules, you have to get the answer. He asked to find which number is opposite to 1. See, now compare these two. If I will compare these two, here 1 is there. Is there any number common? See here 3. From these 3, I am getting 3 is common. But I don't want to find out which number is opposite to 3. If I will say which number is opposite to 3, 1, 4, 2 is not appearing. That's why 3 is opposite to 2, I can say. okay, according to rule 1, but I have to find out the number which is opposite to what we can say, 1 we can say, okay. So rule 1 fails. Now observe these two diagrams, or else observe these two diagrams. Interestingly, observe these two diagrams, okay. So yes, now we got the answer. From first and third, you need not to consider all the diagrams, consider any two diagrams. Ultimately we have to get the answer, whether 3 given, 4 given, however, okay. So let us think that this is first diagram and this is third diagram. From 1 and 3, from 1 and 3, how many numbers are common? Only one number is common, only one number is common, okay. Shall I say this common number is occupies on same surface? Yes, because 1 is on same surface, here also 1 is on same surface. That's why according to rule 3, since these two occupies, rule 3 is not required, because 3 is opposite to 4, 4 is opposite to 2. That is what according to which rule? Rule 3. But I have to find out the number opposite to 1. Number opposite to 1. So now taking all the common numbers. Even I should not take 1 and 3 also. Why? Because here 1 and 4, 1 and 4. How many are common? 2 are common. Since 2 are common, 2 is opposite to 3. 2 is opposite to 3. And from 1 and 2. And from 1 and 2, here 3 is there, 3 is there, and 2 is invisible. However, I am getting 3 is opposite to 2. No issue. Now what we will do? We will apply 2 and 3. Are we getting by applying 2 and 3? See here 5 is there, 4 is there, no common number. Or else from 1 and 2, it is clear, we will apply in this way. 3 and 3 both are common, but both are appearing in different places according to rule 4. Yes, according to rule 4. Of course 3 is common but on different surfaces, okay. Now at that time what we can say? So it is very clear, at that time 1 is opposite to 6 we can say, and 4 is opposite to 5 we can say. Now 1 is opposite to 6 is the answer. I repeat this once again. You can choose any two diagrams, no issue. Now from 1 and 2, so here 3 is common, only one number is common, that common number occupies the different position. Here 3 is on different position, 3 is on different position. So at that time the corresponding number should not be opposite. So that's why 1 is you should not take 4, 6, because they are on same surface. That's why 4 should not be opposite to 6 according to rule 4. 4 is opposite to 5, whereas 1 is opposite to 6. So according to which rule? According to rule 4 we can say, okay. This is interesting part. Now final part, observe here, how many faces he given? He given 4 positions of the dice given, 4 positions given. Take any two. He asked to find out 6, right? So now take any two conditions. Observe first two. Are we getting or not? We will check. 1, 2 is there, 1, 2 is there. According to rule 2. See, for first diagram, 1, 2 is there, 1, 2 is there. So 3 and 4 are opposite to each other. From these two, 3 and 4 are opposite to each other. Which rule? Rule 2. Now from these two, observe these two. So here 4, 2 is there, 4, 2 is there. Yes. See, interestingly, 4, 2, 4, 2. Again 2 numbers left. What was it? 1 and 6. Hence 6 and 1 are opposite to each other. Again by using which rule? By using rule 2. You can use any two, no issue, okay. Now I used second diagram, third diagram, okay. In second and 2, 4, 2, 4, 2, 4, both are common. Eliminating these common numbers, hence 1 and 6 are opposite to each other. So whether 3 given, 2 given, however, you have to, what you can say, you can choose any two diagrams. Accordingly, rule 1, rule 2, rule 3 you can apply, rule 4 you can apply, look at the answer, okay. I hope you enjoyed. Practice more bits.